we got the following graphs talking about data. Our two things we're comparing today is actually how much study time is related to the score of a test. They're trying to figure out test grades compared to the time spent studying. That's the first study. The second one wants to see if there's a comparison between somebody's shoe size and their test score. So I know this might seem like common sense right now, but this is actually how studies are done and try to figure out if there's a relationship between the two. So here's the first one. When my study time increases, so when I study 1 hour, when I study 2 hours, when I study 3 hours, look what happens to my test score. According to this graph, if I study for an hour, I get more or less like a 60%. If I study for 2 hours, I get more or less like a 70%. Notice all the dots are all over the place because not everybody gets the same score, regardless of if they study the same amount. Each person is different. This is why it's called a scatter plot. It's all over the place, but it should be more or less in the same area. Look, if I study 4 hours, I should get more or less either like an 80 or somewhere around there. So notice how all my points in this area, all my points are more or less going up. Now look at graph number 2. Graph number 2 is talking about the shoe size and the score. Now when I have a size of a 6 shoe size, according to this graph, this study, everybody who has a size 6 should get more or less like a 60. Now look what happens when you get a shoe size of 10. And this is actual numbers, like they asked people who have a 10. Look, if you have a shoe size 10, either you score a 60 or you score an 80. Notice how different it is based on shoe size. And can you draw any kind of straight line connecting most of these points? Not really. They're all over the place. So with that in mind, let's see what kind of relationship these could have. Well, look at the first one. A negative linear relationship. This goes hand in hand with slope. When you have a slope that's negative, it's actually a line that's going down. That's a negative linear relationship because it's a line going down. Now you guessed it, positive linear is actually going up. Now what's a non-linear relationship? That means that there is still a relationship, but it's not a straight line. It could look something like this, like a U going up, a U going down, or even like a ramp like that. They're not straight lines, but there is still some form of relationship. And the last one, no relationship. You don't see any pattern to this. So going up to these, which one will be appropriate for each graph? Look at the first one. Would you say the graph number 1 is a linear relationship? I'd say so. And it's going up. So I'd say letter B will be the right answer for this one. Now graph number 2. Is there any way you can form a line? Not even a straight line, just any kind of line. I mean, some people could argue, hey, it looks more like a U going down. But again, it has to be obvious. If you don't really see it, and if you really think about the things you're comparing, then it should make sense that letter D is actually the answer for this one. Because there is no relationship between shoe size and the test scores, as it should be. Just because you have a size 13 doesn't mean you're going to get 100 or a 50, etc. And that's basically how we do scatter plots and graphs in this lesson.